Well, welcome back to engineering class here. Today we're going to talk about multi-view sketching. Multi-view sketching shows two or more two-dimensional views of a three-dimensional object. Provides the shape description of an object. When combined with dimensions, serves as the main form of communication. Well, a couple days ago, and then today as well, we talked about how you're going to convey your thoughts and ideas to someone else from a different company or from a different place. And multi-view drawing is the main form of communication between designers and manufacturers. All right, that's important to know right there. For example, up here, here is a three-dimensional picture. All right, here's a three-dimensional picture. If you look at this one is, who knows what type it is? It is an isometric. How do I know it's isometric? Well, what do you got pointing at you? Right there. All right. Right here, you got a point coming at you. That's isometric. Here is our multi-view. This right here is a multi-view. Every one of these drawings are only two-dimensional. They're either giving us height and width, or they're giving us depth and height, or they're giving us depth and width. But each of these drawings are only two-dimensional. So they are what we consider to be a multi-view. As you can see, this one here is the front. This is our right side. This is our top. This is our left side. Here's another example. Typically, what I want to show you with a multi-view is that there is a set order. Typically, we're going to have three sides to a multi-view. All right, and this one right here is typically our front. This right here is the right side, and then we'll show the top. That is the three most common. All right, those are the most common out of every one that you're going to see. Is they're going to put a front right here, they're going to put the right side and the top. Multi-view drawings. All three-dimensional objects have width, height, and depth. You'll hear us talk about width, height, and depth. You won't hear me make reference to length. If I do, I'll usually correct myself. But we're going to talk about width, height, and depth. Width is the object side-to-side dimension. Quite often, this is what you guys are going to refer to as the length. I'm going to call it the width. The height is obviously pretty easy to remember. The depth is pretty easy to remember as well. Here they're showing us the exact same thing in a multi-view. All right. A couple things I want to point out to you guys right now in the multi-view is, let me use some red lines here. I want to show you something. Notice the bottom of the front view is in line with the bottom of the right side view. The top is in line with the top. All these lines that correspond to each other are uniform straight across from each other. Here, we're straight across. This hidden line corresponds to up here. So all these lines, these are going to be things that are hard for you guys to remember to do, but these are all very important when it comes to a multi-view. The one thing I didn't say up here is typically in the corner, you're going to give an isometric. All right. Notice here we've got our front view, right side view, top view, and our isometric. If real quickly, if you look here, these are indeed all lined up with each other. All right. And then over here is the isometric as well. All right. One of the things I want to show to you is that when making a multi-view, the width becomes very quick. All right, you don't have to spend a lot of time making a multi-view. There's going to be several of you boys that don't pay attention here, and it's going to take you forever on today's assignment. And there's going to be those of you that pay attention. It's going to go pretty quickly. What we want to do is draw in a 45-degree angle. Now, what they don't do very good here is they're 45. Typically, we want to draw a 45 from here. All right, coming from the corner of our front view. And what's nice about that then is you only have to draw one object. When you come up here, let's say you have your right side view drawn. The left side, the top view, I don't have to draw at all. I'm going to move their view. I don't like where they have it. I think it should be right about here. All right, and I'll shade this bottom portion in like they do. Now let's go back to making our drawings. Here's the nice thing then about this 45-degree angle. All right, I'm going to forget about the one they have. I'm going to use the one where I think it should be. All I have to do is draw straight up. All I have to do is draw straight up. And when I hit that 45-degree angle, my other view then would be right here. And what that does now is that automatically makes this distance and that distance, or this distance, sorry, that distance right there be equal to this distance. That right there has to be the same now. And here's the other thing. If I draw my line straight up, it automatically, I have my top figure already drawn in now. I know that it's going to fit right there. If I draw this line straight up, I now have my top view done. The 45 is so very important, all right? Okay, what I'm going to do here now is a multi-view, trying to show you exactly what I mean. All right. This gray line, I'm going to use gray as my construction line. So all I'm going to do is lightly fill in that line. Now what I'm going to try to do is, let's pretend that this is actually getting drawn in here at a 45-degree angle. So there's my 45. Now, I draw in construction lines here. If I just extend these over, whatever that there's going to correspond, and then I've got my hidden line I've got to put in down here as well. So these right there are all construction lines. What I'm going to do now is draw in the sides of this. Let's pretend this object was 1 centimeter wide. Well, what's nice now is I can come in here, draw my lines up, and notice I'm not measuring, but because if I put this in at a 45-degree angle, my top figure is the same size then. Oh, somehow I lost a drawing, a line there. Let's draw it back in. And I keep losing it. It doesn't want to stay, does it? That one, the ruler moved on me a little bit there. Okay. I can now come in here and put my object lines in here. This is the outer parts of my right side view. These right here, this is an object line. Because of that, I don't have the dotted line, but here I'm going to have my dotted line to show my hidden line. Up on top, I have my outer edges. This line is an object line. This line here are my hidden lines. The only other thing I have to add to this then are my center lines. But notice here I didn't have to go over here and using the rulers to measure actual distances. I was able to just project those lines out. Okay, orthographic view selection. What this really means is how am I going to pick my front side is what this means. Is how am I going to pick the front? How to pick the front. Well, first and most important, how does the piece normally sit? I mean, is there a way that the thing normally sits? For example, if I'm drawing a printer, I don't want to take the printer and turn it on its side just because it fits one of these other conditions. If it has the most natural position, that's what we're going to do. Shows the best shape and characteristic contours. That's the second most important. The longest dimensions. That's our third. Fewest hidden lines. And then the fifth is the most stable and natural position, which is very similar to the first one right here. Okay, here's an example. This would be my front view because it gives the best shape and description. It also gives me the longest dimensions. It's also the most natural position, and if I draw this as my front view, I have no hidden lines, no hidden edges. Rules for determining number of orthographic projections. Well, how do I know? Because, here's an example where they drew 1, 2, 3, 4, 5, 6 different orthographic projections. How do I know how many to draw? Well, rules for it. If you're going to have one view, here's an example of where they only had one view. Uniform thickness or shape. Two views would be identical. So if you were to draw two views, all right, and you had a front and the right side, and they both look exactly the same, get one of them and go down to one view. Whenever you have two views that look the same, get rid of them. That doesn't matter if you're drawing four views, five views, six views. If some of them are repeating, get rid of one of them. We don't need to show that all of it. All dimensions properly and easily can be shown on one view. Notice here's an example now of two views. These look different, all right? A symmetrical part. A third view would be identical to one another. Again, we don't want that third view. The second view is necessary for depth. Sometimes you have to show a second view just to show depth. Okay, here's an example of where they're showing us, again, here's our 45-degree angle. That is so important, that 45-degree angle. Otherwise, you're going to take you a whole lot longer. All right, they're going to make the three views of this. All right, they're starting to sketch all the lines. And then they come in and they're showing you how you can put in your object lines, and you do not have to measure all of those measurements. Locate the hidden lines. Notice they're showing us here there's no hidden lines. One of the last things we do is we want to make sure we find those hidden lines. I want to show you some examples of them, multi-views. Here's one that was done in 1913 about a man-sized hunting blind that looked like a duck, a big old duck that a guy would be hunting in. Alright, here's a question for you. Each of the blocks at the right has the same overall dimensions and color. What else do they have in common? They all have the same identical top view. I want you to take a minute and draw what that top view would look like so that you can see they all look the same. When you're done with that, answer the question. All right? I'll catch you guys on the flip side.